Okay, so limiting reactants. Limiting reactants are just like the recipes. Just like if you had a recipe for 24 cookies, but unfortunately when you go to make the cookies, you only have, 1 stick of butter. And to make the cookies, you need 2 sticks of butter. Can you still make cookies?
Yes.
Yeah. You just alter your recipe. But the butter is going to limit how much flour you use. It's going to limit how much sugar you use. It's going to limit how many cookies you make. It limits everything in the entire reaction or recipe, whatever you want to call it. That's the same thing that happens here. One substance is going to limit how much you can make and how much you use of everything. So, I'll put this up here. Okay. So you look over here. Let's say that's an easy way. So let's say we have N2. You guys see this okay? Plus H2 yields NH3. So we got to balance. I'll let you write it down for a minute first. Let me go back. There you go. Okay. You guys can see this. Put this thing up like this. It's right here. Okay. So we balance it with 1, 3, 2. Yes. I'm sorry?
Never mind, I got that one.
Okay. So let's say I use 1.00 grams of nitrogen. Let's see, 1.00 grams of hydrogen. And I ask you what the limiting reactant is going to be. Which of these reactants, hence the term limiting reactant, which of these 2 reactants is going to limit how much ammonia or nitrogen trihydride I can make? Okay? What? Well, it's the same thing. Nitrogen trihydride is ammonia. They're the exact same. Ammonia is just the market term for it. Okay, so I want to know how many grams of this I can make. So I have to do mass to mass. So I start off with, 1 gram of nitrogen. Now, you should know how to do all of the stoichiometry, so I'm not going to slow down and say, do this step, then do this step. Follow your mole map, okay? So I multiply it by 1 mole over 28.02 grams. That way my grams of nitrogen, 1 mole of nitrogen over 28.02 grams of nitrogen. So my grams of nitrogen cancel out. Then I go to my balanced chemical equation, 2 moles of NH3 over 1 mole of nitrogen. And then I say 1 mole of NH3 over 17.01 grams of NH3. Does that make sense? Yes or no? Okay, so then we do the math. And what is it? 17.01 times 2 divided by
1.21 grams.
Good. So this would make 1.21 grams of NH3. Okay? So that's what that makes. But then I have to do it a second time. This time with the hydrogen's mass. So 1.00 grams of hydrogen times 1 mole of hydrogen, or 2.00 grams of hydrogen. Okay? I see a seat change coming very quickly. Okay? I do my mole to mole, 2 moles of ammonia, and H3 over 2 moles of hydrogen times 17.01 grams of NH3 over 1 mole of NH3. Anybody do all that math? Yes, ma'am. Oh, it is. Thank you. 3 moles. Yeah, no, you're right. I was thinking we're making water. Not quite sure what I was thinking.
5.67 grams.
So this makes 5.67 grams of NH3. So you say, okay, which did I make the least of? Did I make the least using nitrogen or the least making hydrogen?
Nitrogen.
Okay, with nitrogen. So nitrogen is my limiting reactant. And this is in excess. And I'm going to make 1.21 grams of ammonia. This nitrogen is going to run out, and that's all I can make. Does that make sense? Now I could do a mass to mass one more time and use my limiting reactant to find out how much hydrogen should I have used. Trent, I need you sitting up with your eyes open, please. Up. There you go. Okay, so I could do 1.00 grams of N2 times 1 mole over 28.02 grams with a 3 moles of H2 over 1 mole of N2 times 2 grams over 1 mole. Griffin, what's that?
0.21.
Good. So I should have used 0.21 grams of that, right? Which makes sense. I could have just done the math, couldn't I? Because this plus this has to equal this, right? Mass-wise. So look, I just proved it. So instead of using 1 gram of hydrogen, I should have used 0.21 grams instead. Because the limiting reactant limits everything. It tells everyone how to do what it's going to do. Okay? Hey. Sure. Wait a second. Okay, put this back on. So does that make sense, yes or no? Okay, that's limiting reactants. You have to do this for every one of them. Now sometimes when you do limiting reactants, you're going to have more than one product. And sometimes they don't tell you what product you have to go to. So let me get this guy. So if I'm doing this acid-base reaction, if I have calcium chloride or calcium hydroxide, sorry, plus hydrochloric acid, and it makes calcium chloride plus water. We balance that. We get a 2 here and a 2 there, I believe, yes. Now if I say, okay, you have 1.00 grams of calcium hydroxide and 1.21 grams of hydrochloric acid, which is the limiting reactant. So you can choose either product you want to go to. If I don't say, hey, how much of this would you make? You choose either one you want. It's being a little loud back there. I would always, well, I always go to either water or a single element or something where I know it's easy to do the calculations. I mean, I really hate when I have like barium iodide because I really don't know those, I don't use them enough. I think I know what their masses are. I try to find one I know all the masses, so I just do it real quick. So you can choose either one of these. You don't, but you have to stick with just the one. So you're going to have to take 1 gram of calcium hydroxide and do it to water. You have to take 1.2 grams of hydrochloric acid and do it to water. You can't choose one and do a different one for the other reactant. Does that make sense? We good? Okay. You want to try some?
Sure.
Okay.